All right, so we'll focus on question 4, and I'll draw all over the screen to get the video started. There you go. We'll focus on question 4. And this is an unusual question because it is just a frequency distribution table, but there's two things wrong with this table. First of all, it goes horizontally, and we're used to seeing them go vertically. And then the second part of this is it doesn't really give you any titles for the other two columns that you guys need to create, okay? And what I mean by that is you've got these blank columns here, okay, that you've got to do something with. Now, you need to remember that each of those columns did something useful for you, okay? So what we need here is we need to create a fx column, and we need a cumulative frequency column, okay? So that's the cumulative frequency, but we're too lazy to write that, okay? So when you find them, I'd just call them fx, so frequency versus score, and cf for cumulative frequency, and it's going to be a bit easier that way. Someone bailed me out the other day and asked me if it matters which order you do the columns in. It doesn't. Whatever suits you more, there's no problem. In some ways, the cumulative frequency is a little easier to actually put in the other spot to what I've done it, because it means you can just zigzag across the row a bit easier, but we'll just roll with this. So what we're doing, remember, is frequency times score. So this one here is the score in each case, and the frequency is labelled for us. And the fx column is the frequency multiplied by the score. So that is 31 times 2, or 2 times 31. So this one is 62, and then we've got 4 lots of 32. And what I'll do now is I'll just jump onto the cheat sheet so that we can just fill this out nice and quickly. So just get these down. You can use a calculator in the test. You don't need to try and do this without a calculator. Okay, we might do the same for Mr. McLeod straight away as well. So it's frequency times score again. So this one's going to be a column of nothing, 2, 4, 6. Oops, I've really done some bad maths here, hang on. This is going to be 0, this is going to be 64, this one's going to be 132, 204, 140, and 0. All right, so focusing back in here again, the other column that we've got to fill out is a cumulative frequency. Remember, cumulative means building, okay? So remember, grab the first number, which is 2, and chuck it straight in here. And then what you're doing is you're doing 2 plus 4 equals 6, and you're just building that frequency up as you move across the column, okay? So then we go 6 plus 3 makes 9, 9 plus 3 makes 12, 12 plus 2 makes 14, 14 plus 2 makes 16. All right, and pause for a second. So everyone needs to be tuning into this, so you guys have got this, right? The reason that I'm doing this is in a specific order, okay? So I've gone through that. Remember, once you've got that number there, that number is also the total for your frequency column. So I would personally be adding totals to this. You'll need it so that you can get your average or your mean. And remember, that old school, you'll have to get out your calculator and you'll have to add up your fx column, and that will give you a total of 533. No shortcuts on that one, you've just got to do it in your calculator. Let's go down and do cumulative frequency for McLeod as well. So remember, I'm grabbing that first number, 0, and I'm dumping it down there, and then it's a building frequency. So 0 plus 2 makes 2, 2 plus 4 makes 6, 6 plus 6 makes 12, that's supposed to be 6. 12 plus 4 makes 16. 16 plus nothing means you've still got 16. Be careful, there's a bit of a discrepancy on the sheet there. Remember that that total is also the total of your frequency column, so take that up here, okay? Now, just while we're at this, and just so that we tie this in nicely for people who like to understand what's going on here, Remember, the question posed that there were 16 races. That's why the frequency total is 16, because it is measuring 16 things, okay? And then you total up your FX columns, and so your FX total is 540 for this one. And what that is for the people who are still, interested in understanding how this works, that is all of the minutes added together, okay, or seconds probably, for the times that have been run, okay? So we talk about average being equal distribution. What we do is we take all, we add them up and divide them by how many there are, but really what that means is we're adding all of the time up and then we're spreading it across the 16 attempts at that run, okay? So now we need range mode, mean, median, lower quartile, upper quartile, interquartiles, all that sort of thing, okay? So we're going to start jumping around. How are we going? Is everyone happy at this stage? Okay, let's keep going then. The range should be reasonably easy. Let's see what they're asking us for. So we're starting with range. In order to calculate the range, what I'm going to go hunting for here is each of these runners' fastest and shortest times, okay? So I can see that Mr. Connolly scored 31 seconds twice, and he scored 36 seconds twice. I'm not really interested in how many times he scored it, but I need to know that he scored it. So he's going to have a range, He's going to have a range of, I keep drawing all over my own screen. He's going to have a range of 36 minus 31. His fastest minus, his longest time, his largest number, minus his shortest run. So that's 5 seconds, okay? We probably don't need to fuss too much about units, but put them in your mid-year, okay, just in case. Let's go back and find McLeod. You need to be very careful in the question. They may try to trick you. They're trying to trick you here. They want you to do the same thing, 36 minus 31. But look, Mr. McLeod did not score a run at either of those times. So his slowest run, his highest number, was 35, okay? And his lowest was 32, okay? So you're looking for where it actually occurred. Don't get tricked by it. So his is going to be 35 minus 32. So he's only got 3 seconds, okay? Everyone happy with that? Don't fall for it. Range is one that tricks people. They're not really sure what numbers they're supposed to be using, okay? So we'll try and colour code this. I'll keep this green for you so you know where I'm getting these from, and then I'll try and swap colours so you know where I'm working. Let's go back. What do we need next? We need the mode. Okay, in this one, we need the score that happens the most, okay? So as a little cheat note for yourself, if you like, make the frequency column where you go looking for the mode, okay? That would be a good little note to make for yourself. This one's the mode. And what we're looking for is the highest frequency, basically, the one that happened the most. So that's going to be 4 for Connolly, and for McLeod, that's going to be 6. Okay, so you're going hunting in the frequency column in order to find the mode. So that will be 4 and 6. Whoa, keep drawing all over it. This. Oh yeah, sorry. Yes, not 4 and 6. You're right. Thanks. Well done. So you need to look at what that score was actually. So Bridie's right. 4 gives you 32. 6 gives you 34. Oh wow. How's that look? Good. So that one's going to be in pink or purple, whatever colour that is. Let's go for blue this time. What do we need next? We need the average. All right, so the average is, and what we'll do is we'll just make ourselves a nice note. Unfortunately, I'm swinging around a lot on you here because of the Answers being at the bottom of the page and the questions being at the top. I'll try and squeeze it in a bit more. When you go looking for the mean, you're going to have to try and remember this because there's no formula sheet in this test. So the average is the fx total divided by the frequency total. If you struggle to remember that, because that's a bit of an odd one to try and remember, I would just remember it as being the big total divided by the small total. But you're going to kind of have to try and give yourself some sort of way of jogging your memory to remember which ones of those columns need totals. Otherwise, you'll get yourself a bit confused, okay? Because if you start adding up the cumulative frequency column and stuff, suddenly you'll have a whole bunch of totals and you don't know which one to use. So even if your cram study is, you know, what should I cram study? Cram study that formula as you're walking in the door of the test. You could be reading that one just to refresh yourself. So for the average for, or mean for Connolly, we're doing 533 divided by 16, and that will give us a total of 33.31. And for the average for, or mean for McLeod, that would give us 540 divided by 16, and that one will work out to be 33.75. All this area here, by the way, is all for your working out. I should really be working it out there. I'm just trying to make it really nice and obvious for you. So that comes from these numbers up here. And again, for the people who are hunting for like an actual reason for this, okay, like when we talked about distributing chocolate and all that sort of stuff, what we're doing is we're collecting up all the time, so all the seconds that that runner ran, and then spreading it across 16 as though they ran that same time 16 times, okay? So we're still trying to find what's central tendency, what's normal by using the average. All right, we're up to the median score. The median score is the middle score, okay? So when we go to calculate the median, what we're going to do is we're going to have a look at the number of scores, and in this case, how many times each runner ran, and that will be 16. And remember, if you need a formula for this, it's +1 divided by 2, because we're looking for the middle score, which will work out to be 8.5, which is a bit useless to us. What we need to remember is that means we're hunting for the 8th and 9th score, okay? Now, this is a bit where I'm never really quite sure whether I'm being confusing or whether this is making this nice and clear. The benefit of a frequency distribution table is that you don't have to have that string of numbers all written out one after each other. But as you go across this table, that's exactly what this table is doing for you, okay? So you're looking at the first and second score here, the third and fourth. Oops, sorry, I'm not reading that right at all. Just ignore that. You are going for the cumulative frequency column. So that is, this one's for the median. This is going to be more confusing, this video, than if you watch the real one. So if you have a look at this, you're looking for the first and second score. This one would be the third, fourth, fifth, and sixth score, the 7th, 8th, and 9th score. So that's going to be the column that we want, okay? And that is a time of 33. So we'll go and write that down before we forget. So we're going 33. Then we need to go and check out Mr. McLeod. He is the 8th and 9th score. So again, we go to cumulative frequency column. No scores have happened in this first spot here. The first and second score happen here. The third, fourth, fifth, and sixth. And then the 7th through to 12th score happens there. So that is going to be a median of 34. Okay. We'll go down and write that one in. Why do you do the 16? +1 bit? So,
why isn't the 16?
so there's 16 scores altogether, and we might go with median back to that example where if we're trying to find the median height of kids, what we do is we arrange them like photo day from the shortest person through to the tallest, and we pick the middle. So if you're able to look at 16 and go, 16 is an even number, so the two middle scores will be the 8th and 9th, you don't need to use that formula. But for people who need something concrete, and for people who might be under a bit of exam pressure and just need something that they know they can be confident in, then that adding 1 and dividing by 2 is a great way to do it, because sometimes you'll get just a whole number. That will happen if you've got an odd number of scores, and that's really cool because you're just hunting for, say, the 8th score. But if you've got an even number, what will happen is when you do it and divide by 2, you'll get the answer like 8.5 like that. You just go down half a number, up half a number, you get the 8th and 9th, if that makes sense, because 8.5 tells you you're sitting between the 8th and 9th. Does everyone feel happy with that as an explanation? Is everyone okay finding them in the table? I never know whether that's very clear or not. Yeah? All right. Right, we need lower quartiles and upper quartiles. So the lower quartiles and the upper quartiles is the new part for us in Year 10. And it's like, if you want to think about it as being like the median between the first and median scores and the median and top scores. So an easy way to do that is go looking for the lower quartile first, okay? And the lower quartile is found in a similar way to the way that you find the median. You're trying to find a quarter of the way through the scores instead of half. So you do the same process, you take the number of scores and you add 1, but this time we're going to divide by 4. And so that means that what I'd end up with is 4.25, I think. But really what I'm after with that is I'm after the 4th and 5th score. So again, we're going either side of it, okay?
Why isn't it 4.5?
Because half of 8.5 is 4.25, but it doesn't make any difference. Yeah, it just, if you dial it into your calculator, it'll give you 4.25, but don't freak out about that. Just go for the 4th and 5th score. All we're trying to do is just find a way of, you don't have to try and lean it more towards the 4th score than the 5th or anything dramatic if there's a discrepancy. And most of the time it'll land on the same number for you anyway. Let's have a look though, because I don't think it will in this case, which is good. So we'll look for the upper quartile at the same time while I'm talking about this, just so that it's nice and clear. If you take the upper quartile, there is a fancy pants way of working this out, but I think it's easier to just take your lower quartile, which was 4.25 or 4.5 or 8.5, whatever it works out to be, and times it by 3, because that will give you the 3/4 mark, okay? Because if we do a little aside here in green pen, if I take a quarter and I multiply it by 3, I end up with 3/4, okay? So I'm looking for the 3/4 mark. And then, so obviously what I'll get when I dial that one out is I'll get 12.75. So now I'm looking for the 12th and 13th score. How does everyone feel about that? Everyone happy with that? All right, let's go and find them. Let's just pick a new colour. Let's go with, I'm starting to run out of orange. That's obnoxious, isn't it? Look at that. Let's go looking for the lower quartiles, right? So when we go for the lower quartile and upper quartile, you're going back to that cumulative frequency count, same one that you used for the median. But this time we're looking for the 4th and 5th score, and it's going to happen here because that holds the 3rd, 4th, 5th, and 6th scores, okay? So that's going to make that one 32. Oops, sorry, I'm on the wrong athlete here. These two fine athletes. And so down in this one, it's going to land here because that's where the 3rd, 4th, 5th, and 6th, but whatever, that's where the 4th and 5th score happen. So that one's going to have a score of 33. Let's go looking for the uppers. The upper quartiles, I don't even know if you'll be able to see through this highlighter, is going to be the, what did we decide? The 12th and 13th score. So back to the cumulative frequency column. Oh, this one's going to be tricky. Look, it falls across 2, okay? So we need halfway between 34 and 35. That's not too bad. That's 34.5. But if it is a tough number, or if you're faced with decimals and that sort of stuff, and you've got to find halfway between two numbers, remember all you need to do is take them. So 34, add it to 35, divide by 2, and you'll get exactly halfway between them, okay? So if you get faced with some nasty numbers that you can't work out, just add them and divide by 2, and that will give you halfway. We'll need this strategy a few times this year. It's good for finding the median score. It's also going to be quite good when we start doing linear graphing, when we've got to find halfway between 2 points and stuff. All right, let's roll. What else do we need? We need upper quartiles. So we need an upper quartile for McLeod. We're looking for the 12th and 13th. It's going to happen to us again. Look, the 12th and 13th score. So now we're going halfway between 34 and 35 again. 34 and a half. And finally, we need the interquartile range. This is a new one. Oh, yeah.
Is it completely necessary to put all the working out on the sheet, or can you just fill it up without working out the exams?
This is a great question. You will not lose marks for not showing working,
Okay, great.
but you will really struggle to find half marks if you haven't demonstrated where you potentially went wrong. I would show some working out in this, not an excessive amount, but maybe like what I've shown on this, just so that if you do get it wrong, we can let you carry an error through the rest of the question, because this question is, you know, worth 11 marks. If you fail at this first point here, you've lost a third of the marks across your entire test. So pretty important that you can get this out. This would be what I'd be studying tonight, okay? All right, let's roll a little bit further. Interquartile range is a new one. So interquartile is just, so if we put this down somewhere, I'm starting to make a real mess of this sheet and not leave much room. The interquartile range is the upper quartile minus the lower quartile. So in other words, what I'm looking for is the range within the middle half of the data, the most relevant. So this one is going to be, don't bother showing the working out, I'm just showing it so you know what I'm up to, but 34.5 minus 32, so this one's going to be 30, it's going to be 2.5, and this one will be 34.5 minus 33, so this one will be 1.5. And that is it. And now we've just got to do something with it. So we'll make that one purple. And I'll just highlight that so you know where I got that from. All right. So if you're watching this tonight, just pause it, make sure you've got all this at this stage, and then we'll roll on. Is everyone ready for me to keep going, or do you want to catch up? All good? Yeah, sure. We're down here? Yeah. I'll just give this pause. So as far as plotting this goes, just be careful, because I'll talk to other parts of the test while I'm here as well. If they give you the mean, if they give you the mode, it is disinformation. You can't get one of those into a box and whisker plot, okay? So not even all of the information that we've collected is relevant, okay? So not all of it needs to go into this box and whisker plot. You have to be careful. What we will use is probably a better way for me to talk about this. What we will use is we will use the range, we will use the median, we will use the lower and upper quartiles, and that's basically it, okay? Now, you normally wouldn't bother showing the working out for the range. You just write it in, because it's pretty simple maths. But when you do this test, I personally would write the range in like we've done it, because now that's going to make life super fast and easy for me, okay? So if I'm plotting the first one here, which was Connolly, and we better make sure we haven't, you'll be able to see this on your sheet, but I can't. So just so we don't get confused as we go, Let's do Connolly first. It's a box and whisker plot. Draw the box first. Start with the lower quartile. And, oh, actually, first of all, you need a label, you need a scale on your thing. So have a quick look at your data. So dart back up the top, have a look at your table, and you've got a range from 31 through to 36. You use this table reasonably, but don't go too crazy. So we got 30, 31, 32, 33. Don't have to go too nuts. All right. And then what we're going to do is we're going to plot this. So we'll start with Connolly, make him orange. Start with your box first. Start with your lower quartile first. Lower quartile was at 32. This does not have to be super duper accurate. Upper quartile was 34.5. And then your median was 33. Complete your box. And now for your whiskers. Your whiskers are just your range, okay? So you want your minimum score and you want your maximum score, which is why I'm suggesting that up here you've written it like this, because we don't have to go hunting for it and potentially make a mistake in this when we're rushing. So we're going to go for our lowest score, which had rubbed itself out, which was 31. We're going for our highest, which was 36. And we're going to draw our whiskers on. Hopefully yours turns out a bit neater than mine. And that's the plot. And we're just going to, another really good point, better label who it is. So that's Connolly. Now let's switch colours. You don't have to do this. I'm just doing it to make it clear. We're going for McLeod this time. McLeod is box first. So we're going to start with the lower quartile. All of these numbers are rubbing themselves out here for some reason. His lower quartile was, what was that? It's disappeared, 33. All my numbers are moving around on me for some reason. So let's drop him in at 33 there. Upper quartile was 34.5. Median score was 34. Complete your box. Your minimum score was 32. Your maximum score was 35. Draw your whiskers. And all good. We're done. Better put his name in there too. McLeod. This is a really good point, and I think we should add it because we didn't talk about it yesterday. You better label who these are, okay? Colour code it like I've done it, or put an arrow over to it without it wrecking your actual box and whisker and making it look like you've got a second whisker on there or something. What's that? Did I wreck? So it's a really good point when you're at this stage, if someone's just raised, coming back to that range, when you write your range in, I'd be doing that little bit of kindy maths on my bit of paper, not because I need to, but because when I go to draw it, it would be really easy with that second box and whisker plot to go for the full range again when it doesn't apply to that set of data, okay? But by having that 35 minus 32 equals 3 at the top there, you're not going to wreck it. You're gonna come straight back to it. All right, now we better talk about this. So the next question is, who do you think's most likely to win when Connolly and McLeod race, and discuss it? Instead of writing, I'll just talk, okay? The first thing to be super careful of, okay? It's in a test, it would be easy to start talking about it as the largest number being the best thing. But in this case, it's a race, so you're looking for the smaller of the numbers. Chasing is the smallest number because you win a race by getting the shortest amount of time, not taking the longest to finish it. So when we're talking about these two pieces of data are really tight. Hopefully in a test you'll get a set of data where, you know, it's got a clear winner. Although sometimes when they're small like this, it makes it a better discussion for you. It's easier for you to pick up more marks. So what we need to talk about here is, clearly, these are pretty tight and it's pretty hard to tell these two runners apart. There's a fairly small range and a very tight interquartile range on both of them, okay? it would seem, if I was talking about these, that if I was forced to gamble on one of these guys, I would go for Connolly. He has definitely run the fastest race in one of those 16, but he's also raced the slowest as well. You've got to be careful of his outliers. So those two numbers that are sitting sort of out here and out here, this one in particular is concerning if you're gambling, okay? But if you look at his median, his central tendency is to run faster than this runner, okay? But it's worth talking about in your answer that McLeod is more consistent, okay? So if you argued that you'd gamble on McLeod because he's more consistent and you're being fairly conservative, that would be a justifiable argument. So there's not actually a right answer to this question. If you can justify it, you'll be right. But whatever you do in this question, don't just write down Connolly, full stop. There's no marks there for you, okay? There's no clear winner here. So it's quite possible that McLeod might win. So you guys need to justify what your answer is. Does that sound okay? Yep. All right.